How many of you have heard of the Serval project? Okay, so you should know Paul then. For those of you who don't know, the Serval project is basically an open phone network system. It's not just open platform, but building a whole mobile network out of these phones. So Paul, if you want to hop up. No, I don't want... Who's got an Android AP phone running at the moment? Who's got an AP running on their Android at the moment? I'm not trying to hack your phone.
Now,
alright,
best way to patch into the video and all that.
VGA.
Super.
And will you need network?
How is everyone doing this morning? Excellent.
Let's take that away from you.
Sure. Let's unplug that for a moment. Minimise my email. How many people here have got an Android phone with them today? Excellent, look at that. Who wants their phone to become part of the Borg-tel this morning while they're here? Fantastic. What we will do, because I think the practical element of this talk is actually a very helpful one. Well, I'll untangle my power cord. So while I'm doing that, so down the front here we have Jeremy Lakeman and Andrew Beddison, who are two of our core developers on the Serval project, where we're based at Flinders University in Adelaide. And they will be available during the talk to help get the software on phones. Now I think you've... Oh, a lapel mic, excellent. Now I need a lapel.
Quick question. Does this apply to phones only or also to tablets?
It can work on tablets. We're not going to guarantee that it works flawlessly on any of them, phones, tablets or otherwise. And if anyone wants to, they can literally just grab the source code for the main component of it off of GitHub and start compiling it on their Linux desktop as well if they want to. Apparently it's 11 o'clock. Okay, that will give me a little bit more freedom. Yep, this should be good. Okay, so some of the thinking that's gone into what we've been doing is really thinking about what the CB radio was in the 20th century. So if you had a telecommunications need, a mobile telecommunications need in particular, before the advent of easy access to GSM networks or the analog network as it was prior to that, well, actually, if in the 1950s, if you were really lucky and you were one of 8 people in the UK and you had the correct model Bentley issued by Her Majesty's something or other office, you could, if you so decided, stop your car, get out, open the boot and look at an amazingly large pack of batteries, valves and goodness knows what else, and a phone receiver, and you could actually make phone calls to anywhere in the world. That was actually the first officially mobile phone. Not portable because it didn't fit through a door. So there are subtle distinctions in these things, and certainly not luggable, which means you can cart it through a door easily. But there was this whole kind of concept out there earlier on of, I guess it's something that we would actually find more pleasing in the open source community, where we want to maximize social value and enable distributed activity. We want to innovate without permission is, in many sense, the core mantra of the free and open source community. And so with the CB radios, if you had a communication need, if you lived on a farm or whatever, or if, like me, growing up in an urban area and just wanted to talk to people for free, you could buy yourself a handheld. Again, special values of handheld. Yes, it could be physically held in a hand without it dropping off too quickly. Unit, or you could have a unit in your car or in your home. And you could happily talk over a range of 5 to 10 kilometres, and maybe if someone was a bit out of range, you'd ask someone to pass on the message, and you had this kind of nice daisy chaining kind of process. Then with the UHF radios, that got embodied a little bit more into the infrastructure. They realised this hopping thing was a really good idea, so they made UHF repeaters that can push the range out to maybe 20 to 40 kilometres. And that was a really nice thing as well. And in fact, actually, in the later days of UHF, you could even get cell call and other features. You could actually dial who it was you wanted to talk to. Every man and their dog could listen on your call anyway, but you could at least selectively dial. And so really, the analogue phone network and the CB radio network, there's kind of this point where the value proposition for your average person in the public living in an urban area in a modern society was, the value proposition flipped from CB being the superior option to, these wonderful mobile phones being the superior option. And of course, it's made a terrible contribution to the business hip culture as well, of people feeling the need to have a thin mobile phone. And who here remembers those wonderful early Motorola phones? You look and you go, look at that, it's like 1.5 inches wide. And then you turn it sideways and knock the guy over who's standing over there because it's like 9 feet deep and you have to sort of hold it out here and, and try and look all wonderful. It's kind of the 1980s and 90s version of having a Bluetooth headset and talking into thin air, and about as socially as acceptable, I would argue. So there was that kind of changeover where these things stopped being as awkward as the CB radio, and people realised, well, actually, it kind of has some advantages. I can actually call anywhere in the world that I can look important in even more places than the CB radio ever let me do. And so people picked up on the mobile phones, and then the 2G networks came out, and they were digital and they were secure. People couldn't just listen in with a radio scanner tuning in to listen to what the Queen was saying to someone else, and all of that kind of fun stuff. And so we really very readily accepted this kind of thing. And we went from there being no supporting infrastructure, or at most a repeater that you'd probably run on a back hill if you had your own property, to suddenly being dependent on a heavily interconnected network and system that is actually very fragile. So, for instance, if two people in here were to actually make a phone call to one another on a mobile phone network, particularly if you're on two separate carrier networks, chances are that call is going to route through Sydney. If, for instance, and I'm very glad that there doesn't seem to be today, if we had another bushfire, as there was in Victoria recently, or here a few years further back again, these have a really nasty habit of cutting out the long-range radio links that these networks rely on to communicate. If you isolate a mobile phone tower, it cannot actually allow local communications amongst the phones on that cell. And so there's just this inherent fragility, because it actually turns out to be really convenient for other economic reasons for them to construct the networks that way. So in realising this, we wanted to do something about this. We wanted to make a network which was actually completely distributed and was not at all fragile in the face of difficulties. And so we started writing software for Android phones. So if any of you scan for wireless networks, you probably see there's a bunch of ad hoc nodes at a mesh.servalproject.org. And that's a bunch of phones that we have floating around. I think, ask how many phones this phone thinks it can see at the moment. One of these phones doesn't work. So I can see that there's half a dozen or so phones, and I can, in theory, call, and hopefully the call will actually go through. Assuming that phone's actually still on. That one doesn't seem to be. We'll try another one. But the core point being that you don't have to rely on on infrastructure outside of where we are. And as much as there may be some difficulty in establishing calls in a really dense area here where there's like a gazillion of us with Wi-Fi and there's goodness knows how many access points, once you start going out into areas that are lacking infrastructure, if you talk about the developing world, you talk about rural and remote areas, then suddenly this becomes a much greater issue. And if you start talking about people who are living in regimes that are, shall we say, less than benevolent, then this becomes a real issue where the mobile carriers may, in the very least, be monitored to listen to what you're saying to people so that you don't have freedom of expression and privacy, or they may in fact actually try to deprive you of the ability to communicate. And there are various political reasons for doing that, but from our perspective it's still a disaster. A disaster is anything which overwhelms the ability of a local community to actually maintain normal civil functions. So whilst the government and a rebel group, for instance, might be having barney spats about who actually runs the country, the poor people on the ground are actually the ones who are trying to work out where the food is, trying to work out how to stop the rape gangs coming through, trying to work out, to be able to say, okay, well, that bridge is broken because those idiots have gone and blown it up again. just all of that kind of stuff that you actually kind of need to coordinate becomes really hard. And so we want to try and address some of those things. And we've also been working with the Commotion project, which is out of the Open Technology Initiative, which is from the New America Foundation in the US, who are working in this space as well. And what's been really interesting with that is we've been working with the mesh phones as one part of that solution. Open BTS units is another part of that solution, so we can basically actually run a 2G GSM cell, and that can actually mesh to the phones, and that you can just dial happily across that network. And in talking about the title of this concept of a Borg-tel, if you can chop that network however you like and isolate it into separate pieces, and each piece actually is still a fully functioning network. The minimum functioning network unit is just one phone. And again, when they come together, they actually reform the network. And by thinking carefully about the protocols and things, and we'll talk about some of this later in some of the other talks here today in this mini-conf, we can actually, for instance, we can send an SMS message or a mesh MS, as we call it, on the mesh, or a file, including software updates to the mesh software itself via the mesh, and have that actually store and forward to a delay-tolerant network and replicate from device to device. And so if the network petitions and an update comes into one side or a message comes into one side, if at any point one of those phones actually crosses into the other petition, or the petition rejoins even briefly, that traffic can actually flow across and they'll actually eventually synchronize. And so it's an incredibly simple, yet incredibly effective and resilient approach. It does, as Ms. Gallagher, sorry, you're waving a hand. Am I running out of time?
No? I've just got a question.
Yes, please.
How do you get around the problems with most Android phones connecting to ad hoc networks?
Okay, so yes, and this is a fun one. So it introduces a petitioning problem all of its own. So the quick answer to that is Android has atrocious ad hoc support. Bug 82 filed on Android is ad hoc doesn't work. And there is a gazillion comments on it. Feel free to add some more comments to that. Feel free to write to everyone you know in Google and say, hey, we really care about this from a social resilience perspective.
Comments don't help us.
No. Sorry?
You have to star the issue.
Okay, yep, star the issue then. And talk to people in Google, talk to people in Android. If you're passing through San Francisco, knock on their door and ask to talk to people in there. We need to try and raise this issue. And from our perspective, it's a matter of life and death potentially for people to be able to communicate freely. The really funny thing, Android is hopeless at it, but you know what? I'm actually in the process of switching over to using one of our phones. I need to order a new phone that's a little bit bigger screen than those ones for my personal phone. And then I will stop using my Nokia phone. But I've actually held on to the Nokia phone in the hope, actually, it's turned out a vain hope so far, that we would have the time and energy to port to Symbian, because Symbian actually has full ad hoc support out of the box. You don't have to root it, you don't have to do anything. And actually the antennas in Nokia phones are way better than anything in any of these other phones. The Samsung Galaxy S2s, of which we have a number, we estimate vary by about 10 dB, depending which way you're actually facing the phone. So this is a bit of a problem for mesh routing algorithms where, I'm standing here and I turn around 90 degrees, and my effective range is actually reduced by a factor of 3 in the direction of where I was sending data to or from. So this is a bit of a challenge. Our big solution, well, two solutions to that, and we'll talk about one of them in a separate talk later today, but so the two things are this store and forward mechanism happily lets the phones petition. So we can flip phones from access point to client mode and have this kind of stop-start grid jam traffic style movement. No good for real-time voice, but we can do mesh MS, we can do file transfer, we can share points of interest on a map, and we'll talk about several maps again in a later talk today. A completely distributed offline mapping service where you can actually mark up things. No, that is a time mark, was it? Was it a scratch? No?
No, that was it. I'm really sweaty, so I'd like
okay, yep, easy done. So, someone just tell me if I need to stop blabbing, basically.
I've got the schedule.
Super. So that's one solution to it, and that will let non-rooted Android phones participate in the mesh in a slightly second-class way, but actually still quite a nice, effective way. It just increases the latency for the text and file transfers and means that you can't do real-time voice. Oh, someone's calling someone. So what we might actually do, do you guys actually want to start wandering around and see if you can actually start installing on some phones while I'm yakking away? Our longer term solution to this problem is actually we want to commission a separate device. And as I say, we'll talk about this in the Arduino-equipped phone talk later in the day, so feel free to come back for more information on it. But basically, we want to make a cheap mobile phone-like device that when you flip the back cover off, it's actually an Arduino on the back of the phone. So you've got the battery, you've got the processing power of a processor, everything we need in there, the Wi-Fi. And we can then add arbitrary RF front ends onto that. So we can totally bypass Wi-Fi, which actually, honestly, sucks for mesh communications and mesh telephony.
Have you tried talking to the Cyanogen project?
We haven't in any serious way as yet. We've actually wanted to get our software to a more mature point than what it has been. Which actually reminds me of another thing. We actually have, so the version that Andrew and Jeremy can put on your phone today is actually much newer than what's on the Google Play market. We have quite an old version there, which will get updated to a newer version over the next few days. We're just in the final process of doing a release. But what you're actually getting here is actually newer again than what we're putting on the market, and has some nice improvements. And if you have it installed here, we actually have a server that will actually let you make phone calls out to anywhere in the world. And if I can remember the inbound phone number for it, you can actually receive calls in from anywhere in the world, and it will then prompt for your mesh phone number and try and route the call through. But I think, is Jeremy shaking his head or nodding? Or? Okay, we're not going to try and set it up at the moment. But hopefully at some point during the week we will have that up and running. As well as just being able to do mesh things here on campus. And I've lost my train of thought. So, yes?
Well, let me ask you a question then.
Sure.
I recall with the OLPC that it had special support for mesh networking, and I want to say that it was different than typical infrastructure or ad hoc mode, and I forgot the name of it.
802.11s?
Yes, maybe that was it.
Yeah, so 802.11s, we actually had someone from our civil project funded to engage with the IEEE. We had them there for about 9 months. And one of the things that we rapidly discovered that said, 802.11s is the answer. And we looked into it more, and we're like, 802.11s is designed for a maximum of 32 nodes, I think it is. Like that's their idea of a big mesh, and Wi-Fi Direct has a similar kind of issue. And 802.11s, as it turns out, is kind of designed for you to have an access point connected to the rest of the world somewhere. Ideally, that can bill someone for something, and to extend the reach of that ability to bill out a few more hops. It's a slightly cynical take on it, but it's a sense that it's still kind of tied to infrastructure. It doesn't get you, as I understand it anyway, totally free from that kind of infrastructure bind. And so one of the things that we want to do, and again, I'll talk about it a bit more in the Arduino phone talk later, is we actually want to use a very different RF air interface. So we want something which is much lower power to listen. So Wi-Fi, whatever the flavour, the listen current to have your Wi-Fi card listening for inbound packets is nearly the same as to actually transmit a packet. Because it has this kind of crazy convoluted multi-subcarrier fancy encoding, and hey, it's great, it gets this high data rate, and that's really, really good. And when I say it eats lots of power, I mean like half a watt. It's still not outrageous, but when you're talking about one of these, you want to get your listen current below 1/10 of a watt, probably actually ideally down to 1/100 of a watt. And so we're thinking about some much lower bitrate radio interfaces that get that property. And in thinking about it and sort of eyeing off the ISM 915 band that lets you transmit at 1 watt instead of 100 milliwatts. So that gets you a nice range boost there. The shift down in frequency gets you a further range boost. So for people interested in dB, the lower data rate will get us about 8 or 9 dB. The lower frequency will get us another 8 or 9 dB. And what was it? There was another source of a few more dB. What have I forgotten?
Turning off everybody's microwave?
Yeah, look, that would be fantastic. We're moving off the microwave band. So the propagation characteristics, bit rate, and the power. So it's 10 dB from the power, 8 or 9 dB from the bit rate, 8 or 9 dB from the frequency. So you're talking about close to 30 dB. So close to 1,000 times the effective power. Every 6 dB roughly doubles your range. So we're talking about 16 to 32 times the range compared to Wi-Fi. That's a big deal for mesh networks, because you go from the order of 10 or 20 meters in here to actually saying, well, hang on, we could actually talk to someone in one of the other lecture halls quite readily, and if we're all outside, we could talk over the entire range of the conference without actually touching a piece of external infrastructure. And so our vision is to have that thing in your pocket. that will do that, and of course it will run Wi-Fi, so everyone in the room would actually make use of it. You don't all have to own one to make use of the one that I'm carrying in my pocket. If mine goes flat and yours hasn't, my phone can switch over to yours. Maybe one day they'll even be smart enough to go, hang on a minute, there are 10 of us in the room. We can save power. And then 9 of them can go to sleep and ask for someone to wake them up in due course. One of the other really fun things, just from a geeky perspective to some degree, but actually a practical one, on the 915 band you have to do frequency hopping. So every few milliseconds you have to switch which frequency you're using in order to fit in the regulations. What we realised is if we actually do that switching nice and quickly, we make it long enough to get the packet headers through, and every device says, okay, I'm going to listen on, say, a quarter or 1/8 of the time slots. So I can work out when you're going to be listening on a particular frequency, so I start transmitting your packet. You hear the packet header and go, hey, that's for me, and you stop frequency hopping. You stay on the channel and receive the entire packet. Everyone else is busy hopping off hither and thither, potentially doing the same thing. So you can actually have potentially 50 packets in going through at the same time. So the fact that we're using 128 kbit sub-channels, if you like, we actually can still get like 6 megabits over the ISM 915 band in aggregate. And it kind of enforces a really nice fair share kind of thing where, like with Wi-Fi, one user can kind of like swamp and spam the whole thing. In this context, actually, it's very hard for a single device to deny everyone else use of the channel because you're using much narrower transmission beam width. So that's some of the things, and as I say, we'll talk more about that, but I'm happy now to take further questions that people have, I think. Yes?
Can you repeat the question?
Yes. Sure.
I have a real question.
Yes.
What's the longest range you've actually got in the field?
The longest range we've had in the field? Using HTC Dreams, the original G1 developer phones, which actually have a better Wi-Fi antenna. They also deplete their battery in about 2 hours if you have the Wi-Fi on. So there's a bit of a trade-off. We didn't measure it exactly, but 300 to 500 metres in clear line of sight conditions. With the newer phones, typically you get about 150 metres range on the Wi-Fi. Yes, I did completely forget about putting slides up. So we'll get where's my, no one needs to see my email or my travel arrangements. We'll just pop up the, yes. Oh look, I caught a plane recently. Yes. Does anyone know how to make that go full screen on a Mac? Sorry? Sorry? How about that? No. Oh look, pretend. Yes. That kind of worked. Okay. Yes.
If you have an internet connection in this room,
Yes. If you don't, once someone's got it on their phone and that person goes into the Share Me button on the serval mesh, it'll offer Bluetooth, I think.
you can share by Bluetooth from phone to phone.
Yes.
I also have an access point in this room running mesh.servalproject.org on a phone, running a web server that can also be used to download it.
How did you connect to that?
There it is. Yep.
If you connect to
It's an open point.
mesh.servalproject.org running on here, there's a web server running on 192.168.43.1 port 8080.
It's easy.
Yeah, it's easy. It's a bit hard to run inline proxies to redirect everything.
It won't give you an address at any time.
Oh, that's unfortunate.
Is there a trick to it?
Shouldn't be. It should just work.
Have people otherwise got internet access in here working? Yes.
I was just going to ask a question about ensuring the security of the links. I mean, if
Yes.
you're targeting this at an area that is governed by a despotic regime, it stands to reason that they might procure one of these devices in order to eavesdrop on the conversation.
Okay.
So how can you ensure that people aren't targeted based on what they might
Okay, so we're talking here about in a despotic regime, how do we ensure security of the communication so that if, Osama bin Laden's uncle or whatever got one of these devices and decided that they would eavesdrop in on the communications, they can't. And actually our main talk on Wednesday, we're talking about the entire security framework in the serval mesh. So the phone calls and the text messages that you send and receive on this are encrypted using 256-bit elliptic curve crypto, which is much, much, much better than what the 3G networks support. In fact, actually, what the 3G networks support and what they use are very different. What they support is tolerably okay crypto. What they typically use is woefully poor crypto. And 2G networks kind of use, by the advance of Moore's law and everything, the equivalent of ROT13. It's really quite inconsequential to break the 2G encryption. So the security thing was actually something that we started thinking about very early on, because it turns out that even in a disaster situation, having privacy of communications is actually really important. You might, for instance, be trying to seek medical help, and there's actually no reason why in a disaster you have any less care about the privacy about your health records and things than in normal times. And in actual fact, in any country that has privacy laws, they actually still apply totally during a disaster. And in the past, there's kind of been this kind of cavalier approach to disaster relief, where people kind of take the view that, well, hey, we're stopping people from dying, so we kind of ignore some of these other things. And look, it has still saved lives, but the industry, if you like, around disaster relief is realising that we actually need to do the best that we can, so that we don't have situations. I remember talking with some of the people from New Zealand Red Cross who we've worked with, and we'll be talking more about that in another talk this afternoon, about people going in and basically amputating legs that actually, with a bit more forethought, probably actually didn't need to get amputated. And so it's just the people lived, but they could have lived better with a bit more care. So we're trying to cook things in right from the begining.
So it turns out running mesh.civilproject.org as an ad hoc mesh and an access point in the same room at the same time doesn't work very well. So I've renamed this to ap.civilproject.org as the hot access point that you could download hopefully the web server on here and download a copy of the application. ap.civilproject.org.
192.
192.168.43.1 or 8080.
And everybody wants to find erupting the flames as people find out.
As if MobileFOSS is tiny.
Yes.
Device here.
Hey, we can slash that a phone mount.
Yeah, that's right. Oops, is that the right button?
Sorry, so once you've got the app, do you need to connect to another phone's ad hoc network to be able to talk to them? Is that
well, we'll use any Wi-Fi network that you can connect to and try to use broadcast packets to discover each other.
Yeah.
It works or not on every access point to your question.
And so to be clear, the Civil project, it's functional insofar as it's demonstrable, and we've made great advances in what it has been. There's still more work to do to optimise, particularly on this whole sort of Wi-Fi front. And as I say, our long-term goal is actually to use a mesh helper device and actually say, hey, we can actually solve practically all of that problem with a nice helper device that actually increases the utility of it, 100-fold or better compared to relying purely on the Wi-Fi on the phones. Yes?
I guess you probably looked at Bluetooth. Were there too many trade-offs and limitations with trying to use Bluetooth for some of the, at least, discovery aspects?
So the question is about, we thought about using Bluetooth. We have. To some degree, we haven't had the time and resources to actually put it all over Bluetooth. But also actually what we've discovered doing file sharing on Bluetooth is it actually has many of the same degree of interoperability issues as Wi-Fi. And it follows the same kind of vendor lines. So, Bluetooth sharing from Samsung to Samsung probably works fairly well, but Wi-Fi from Samsung to Samsung actually works fairly well. Whereas, from those to the little Huaweis is probably harder on both fronts.
If anyone's really stuck, I've got the APK here.
Super. So who's trying to get it on and is currently frustrated at trying to get it on? One person? Okay. Do you want to actually... Yeah, or Jeremy, have you got the APK on your laptop and we can just do...
I do, because the last resort.
Yes.
I'm always using the USB cable.
While they're installing code, does anybody have any more questions?
Yes.
So now that I'm associated with that access point,
yes.
I've got the software running,
yes.
and it says I'm in a mesh with 3 phones.
Yes.
Now what do I do?
So the easy thing to do if you want something fun is you should, as soon as I wake my phones up, you should be able to go into the peer list.
So there's contacts on the main menu, there's a button in the top right.
Yep, contacts. And then list phones on the mesh. And the Wi-Fi in here is very congested, so it may take a while to show the phones.
So if people are on the Linux.com AU network, they'll be two separate meshes?
Correct. So what we might, in the lunch break or something, actually have a look at, see if we can actually get, because the mesh should actually work on that. If everyone actually puts the mesh on there.
Explaining how the two different Wi-Fi, I suppose.
Yeah, do you want to, over to the microphone so people can.
The way that the software is written at the moment is that in the settings menu you'll find a Wi-Fi settings button, and that will take you to something, and the two top options are Wi-Fi mode and then automatically cycle Wi-Fi mode. Turn off automatically cycle, because that's what we've been using for our general deployment, but at this conference that's not really relevant. The Wi-Fi mode at the top, you've got a choice between ad hoc, client or access point. You're only interested in ad hoc or client. Now, the way that we've been doing our serval development so far is mostly using ad hoc. If you just take a bunch of people, send them into the Outback with a bunch of phones, they'll all want to use ad hoc mode, which basically means all the phones talk to all the other phones that they can. There's no such thing as access points. It's purely decentralized. In here, if everyone simply selected ad hoc mode on that, we would all see each other's phones, and apart from all the interference from all the Wi-Fi signals that are going on, we'd be able to phone each other, share files amongst each other. In fact, it would be sharing files automatically. The other thing you can select is client mode. Now, if you select client mode, you'll need to associate to some sort of Wi-Fi hotspot, one of the open ones or one of the ones that's around here, that has a connection to the internet. Because in my dorm room, we have a server running, and that server is running as a serval router. And if you put your phone in client mode, it will effectively, through the internet, contact that, and via that detect all the other phones in this room, and in fact in the rest of the world, that are also in client mode running the LCA version of the software. So all of the serval meshes that you're installing now has been pre-configured to connect in client mode to that server that's running in my room at the moment. So that's just a special provision just made for this conference. So if you want to, you can just get together with a bunch of friends and say, hey, let's all go into ad hoc mode. And all you'll be able to do is talk with each other and anyone else who walks past, who happens to also be in ad hoc mode. Or you can all go into client mode, hope that the Wi-Fi and the internet's fast enough that you'll gradually see each other on the peer list. And then if you try making phone calls to each other, you're at the mercy of the speed of the Wi-Fi and the speed of the internet and the speed of the cable connection in my room and so forth. So, you know, your mileage will vary, but those are the two options you want. So at the moment, we're running practically all of our phones at the moment in client mode and just taking advantage of whatever Wi-Fi we can get.
I think we've got enough time for maybe one more question. Yeah, you've been...
Yes.
What phone have you found is the most useful for this?
The phone that's the most useful with these?
Yeah, if you were going out and buying a phone,
sure.
to do this,
Probably the Galaxy S2s.
Yeah.
Probably the fastest good phone.
even though the antennas...
Yes, even though the antenna is dreadful. But it's only moderately more dreadful than most other phones. And it depends in which direction as to just how dreadful it is.
So are the various vendors interested in improving their antennas?
They work enough.
Yeah, they work enough. And I think the trade-off for them is, I mean, you've got a little teeny tiny thing, and it needs to have a really good cellular radio, which actually most of them don't. And you need to optimise the performance of that. And then you go, okay, now where the heck can we squeeze the Wi-Fi in? And I suspect with the S2s, the problem is it's probably gone, I know, between the battery, the RF shielding, and some other large piece of metal or concrete that's hidden inside the phone. And there's a sort of, there's like this one sweep angle where it can kind of, spit the signal out. So that's kind of the trade-off there. And again, that's why we're looking to make a helper device so that we can actually avoid all of that problem. And if we want to help with that, that would be really fun. So come back for that talk.
Also, where can they find, where's your website?
Servalproject.org. So take the AP dot off the front and you'll find us there.
Right, well, thanks, Paul.
My pleasure.